of Applied Sciences, Finland. But he has already delivered this talk on 4th October 2026. But some of the participant has not attended because they registered this FDP later point of time. So I am playing this video of a lecture by Professor Rajeev Kumar Kanth. And if you have any question, you can write in the chat box or you can send to me. I'll forward to Professor Rajeev so that he will reply you. But now I am going to play the video for this particular session. So I welcome all the participants to the ATAL online 6-day faculty development program on optimizing next generation computing for smart system development. So in this session we have Professor Rajeev Kumar Kanth, who is a principal lecturer of Savonia in University of Applied Science, Finland. So I welcome Professor Rajeev to this session. So before he start discussing upon a topic related to our faculty development program, so let me introduce Professor Rajeev. Professor Rajeev received Doctor of Science in Information Communication Technology from University of Turku, Finland in 2013. He has been working as a principal lecturer at the Savonia University of Applied Science, Finland, where he focuses on teaching and research on Internet of Things. He has been an adjunct professor at the Department of Computing, University of Turku, Finland, and honorary professor at University of Environment Engineering, China. He is currently a senior member of IEEE. Previously, he worked at the Indian Space Research Organization of Ahmedabad, India, and the Royal Institute of Technology, Sweden, where he was a researcher and a senior research scientist, respectively. He has more than 25 years of experience working in both academia and research institutions. His current research interests include Internet of Things, Big Data Analytics, Artificial Intelligence, Wireless, Cloud and Edge Computing. He has published more than 100 scientific articles in peer-reviewed conferences, proceedings, and referred computer science and communication technology journals. Some of the recent ongoing research development projects are UCND loan funded by Finnish Ministry of Education, DLE FACT by US Plus funded project, and AIQU SEC by Business Finland. So with this short bio, I request Professor Rajeev to start the session. Over to you, Professor Rajeev.
Okay, thank you very much, Dr. Sanjay. Actually, we met, I think, a few years ago in Odisha, and it's a pleasure to be part of this ATAL faculty development program, which you have been organizing at National Institute of Technology, Warangal. So I would like to thank you personally and also NIT Warangal actually for giving this opportunity to share some of my research. Actually, I asked you yesterday that what would be the topic. So I in this talk today, maybe 1.5 hours, I will be going through some of the research, some of the teaching pedagogies that is being used at Finnish universities. I'm going to talk on that today. So I would like to thank you, and it's my honor to be part of this ATAL faculty development program at National Institute of Technology, Warangal, India. So, so let's go further. So I do hope you can see. So a little bit, of course, Dr. Sanjay has already introduced me. I will try a little bit shortly about my short introduction also. So as you can see the screen, I have obtained this Doctor of Science, particularly Information and Communication Technology from University of Turku, Finland, 2013. I did, after my doctoral study, I had very good funding. I got a very good funding from Royal Institute of Technology, which is called KTH. KTH Stockholm. KTH, it is in Sweden actually. So I went there for 1 year, and then I did my postdoctoral research, and then came back to Turku again actually. In 2019, if you see, now I got this docentship in data science, actually, where I was focusing more on this machine learning, deep learning kind of things. So we have our 5G private network at Savonia University of Applied Sciences. We have been doing lots of research with 5G and also the forthcoming 6G technologies. Currently, I have 3 PhD students working with me. One student has recently graduated. And I would like to tell you, I took one student from NIT Surat actually, and in last August, he has graduated with this generalizable AI foundation, his topic was, and he graduated with honors from University of Turku. We have a very good collaboration with many Indian universities, also from China. I have been offered this honorary professor at Hebei University of Environmental Engineering recently, where we have very big education projects actually with Savonia University of Applied Sciences and also Hebei University of Environmental Engineering. When I talk India, actually my father usually from part of India actually, he was there. So I have a very when I see the Indian researchers and scientists, I'm very overwhelmed actually. So I work at the Space Application Center, which is in Ahmedabad, which is part of ISRO, Indian Space Research Organization, in 2007 and 2008. Actually, I did a course there. It's a postgraduate diploma in satellite communications. And that course was very good course, I would say. Lots of professors. I had a opportunity to visit all these ISRO centers, including Sriharikota in the launch pad, which is in Sriharikota. Lots of your the payloads are being launched from that launch pad actually. So I had the opportunity to. I was also looked at this Chandrayaan mission actually during 2007. First Chandrayaan mission, it has started 2007. So I was in Bangalore at that time. Currently, I have 3 projects running actually. This one project, UCN drone, which was, I think this has been ended already, or university collaboration network drone. So we have been doing, and we have been seeing that what kind of education and research are necessary in the Finland actually, in Finland within the drone education and research particularly. This is one, and I was the project manager for this project also, which was funded by Ministry of Education. And another one project, maybe today I'm going to talk more on this AQSEC, which is we call it cyber security solutions in critical infrastructure actually. So like AI enabled post-quantum and quantum safe cyber security solutions in the critical infrastructure. This AQSEC means that. So we have been doing, and maybe I think there are 5-6 slides on this, my project results that I'm going to talk. I have been very much heavily involved in teaching as well. My courses are like in IoT, Internet of Things. We have started at Savonia University of Applied Sciences bachelor degree program in Internet of Things. And I would like to tell you that we have recently started our India collaboration. In this course in IoT bachelor degree program from India, we have some students coming from this January 2026. Actually, we have been organizing. I have been teaching this artificial intelligence course. I'm also looking at the sensor technology, environmental monitoring, and then also environmental data analysis, which both of these courses are I'm teaching at China actually. I have more than 27 years of teaching and research experiences, and I have been very heavily involved also in giving invited talks and keynote talks, and also some research presentations all across the globe. If you are interested, you can see my page here. Rajeev Kumar Kanth.com. So I will go once again to the next slide. The agendas for today's discussion. So first of all, I am going to talk like a little bit of our university and what kind of educations we are offering to the world particularly, and also the Finnish students. So I will talk a little bit about that. In my talk also, I will include a couple of things, the teaching pedagogy, because I know that this ATAL development, faculty development, FDP, faculty development program is lots of teachers, researchers, research scientists from different universities in India. So maybe I would like to tell you what we focuses on in the Finnish pedagogy and so on. So then I will move to some of our national and EU level projects that I have been involved. That I mentioned you, I think the Professor Sanjay already talked about the value effect. One of them, like virtual learning environment for a smart factory. We have this AQSEC project, the UCN University Collaboration Network for drone education and research. So I will talk a little bit on that. Then I move to some of our group research actually. So group research like YOLO-based object detection, which is recently we published. We are now working with some of the databases and which would be public for all of the researchers. So you, maybe if you are working on this, and this has object detection from this Helsinki Port Authority actually, like Port Harbor Authority actually, we took this object detection. Approximately there are 6 to 10,000 different classes of objects are there, like cars, trucks, like tram and van and so on. Then I will move to little bit robotics and artificial intelligence. We have our one infrastructure, particularly water lab, which has lots of, and we are working very closely with this AQSEC project, which I mentioned. These are the 2 infrastructures where we do most of our experimentation, and also the smart factory, which is German-based demo factory, which we have from the Lucas Lulle company actually, and we have been doing lots of experimentation in the different aspects of like ERP, enterprise resource planning, manufacturing execution system, MES, and PLM. These are the 3 portions where we work. Also a little bit edge computing and 5G edge computing and so on. So then I move to this AQSEC project results, and then as I mentioned earlier, we have this Savonia 5G private network. We have done some of the researches, and maybe I would like to show you some of the demonstrations of our work where we could see that how 5G technology could be used in industry. For example, why this low latency and high data rate 5G is useful in several applications, and we have worked one of the experimentation where you could see that how 5G could be better than general Wi-Fi systems what we have here. So, and then I think we could I will go through some of the solar cell research results, which you can the solar cell which my PhD students recently did and graduated. And then we move to some of the robotics research and some research results and so on. So this is the agenda for today's discussion. So let's move further. So this is, first of all, I would like to tell you, I'm situating now at Kuopio, Finland, which you see here, which is Kuopio. If you see here, Kuopio it's a small country. Probably you might know about Finland. Finland is a very small country, and like only 5.5 million population approximately. I live in Kuopio. I did my doctoral study from Turku, which is southwest part of Finland. Helsinki is here, if you see. So, and currently I'm living in Kuopio. So that is and Savonia University of Applied Science is situated actually at Kuopio. We have 3 campuses nearby, like one is Varkaus and also one is in Iisalmi. So we have 3 campuses, 2 campuses in Kuopio and 1 campus here. So we have altogether 4 campuses. So if you see the Kuopio is known as lakeland, like a harbor town. Actually, if you see, we have plenty of water here in the Kuopio, and lots of like island. If you see small island like that kind of, so plenty of water. It's a very green and so on. This is our, I think, couple of pictures that I wanted to start with here. This is our library here in the second floor at Savonia University of Applied Sciences. And I think we have some students. We currently have lots of students from Asia Pacific region, also from Europe. We have some students from South America as well. Very few students from North America as well. We have been cooperating with more than 200 universities across the globe, including Canada, South Korea, and so on. So I think most of the students are coming to visit us and do their exchange study at Savonia University. We have one EU initiative, we call it Erasmus exchange program, and we have been heavily involved with that, with more than 50 or 60 European universities. So let's talk a little bit of our this is a little bit our Savonia goals and missions and vision, for example, what you say here. So this is like 21 to 2030. So we wanted to be a partner for sustainable growth and expertise in time of business life transformation, actually. So we are following this UN goals, sustainable development, which promotes also the human security particularly. So we have certain values, certain choices, we have certain policies and a vision actually. So let's go. So values are reliable. We want to be a very reliable partner across the globe with any universities or any university of applied science. We are doing things for the community. We have like focuses on our choices are like personalized education. Probably you know this personalized education. We have in Europe, particularly, very teachers to students ratio is quite reasonable. Demand-based continuous learning, we are focusing. At the same time, we are teaching, but also RDI is part of our, I would say, in the teaching plan also. So we are doing also not only teaching, but RDI is going at the same time. We have been offering some services to our local, regional areas, different types of expertise, for example, and so on. We have like business center here and Digi Center. Digi Center, I am looking at this infrastructure-wise and education perspective. I am the Digi Center. We have very nicely collaborated with our infrastructure in the Digi Center. Our focus area are like water safety, food business, well-being technology, engineering, and energy technology. We have energy technology also. We are focusing more in engineering. Particularly, we have IoT, which is Internet of Things, and mechanical engineering. In mechanical side, we have bio and circular economies, multidisciplinary RDI, and so on. And then this is the vision actually, Savonia 2030. So probably you know co-development in education and RDI activities. We have been creating a hub, we call it Sabi Lati Hub. This is, I would say that smart community, I would say, more than 150 companies, most of them are related with working with ITs, also energy, for example, and very good cooperation with university in the Sabi Lati Hub actually. Internationality is increasing a lot. For example, we have now cooperation with mostly many, and we have been exporting our education to India, even also in China also. So this is meaningful and productive, and students' well-being is the part of our goal actually, one of the vision of this. So with the numbers, little bit, I would like to talk. We have approximately 8,000 students. 30,000 alumni, so 30,000 graduates already. This data is maybe, I would say, 1 or 2 years ago. So maybe these numbers could be a little bit changed. Business partners, we have 2,300. Now, usually this number shows that 90% of our students get employed, and maybe some of them are continuing their education in master's or higher level research or PhD and so on. We have approximately plus 600 employees, and RDI volume is like 14 million euro yearly, and turnover like 15 million euro actually. And the cool thing of our university is we want to retain our students in the area where this Isalmi, Kuopio, and Barkaus, you see 3 campuses here. So actually in Kuopio, we have 2 campuses. One campus is for dance, and another campus is for engineering technology. Also, we have tourism. We have, for example, nursing science, and so on. And Barkaus, we have energy, and Isalmi, we are focusing mainly on agriculture. So this is Savonia University Applied Sciences. So this is one of my class here, if you see. So this is one of my class where this is 2020, I think, IoT students, they are learning, and they are learning in a group. For example, I can show you the students are from approximately 20 countries actually. I think this guy is, I think, Manuel Fernandez. This is from Estonia. This is from Finland, Ireland, Egypt, Ghana, Russia. So let's have a look like how the students are, the class environment. Maybe I would like to show you for a while. So they are working on one of the tasks that I gave to the students. This is a couple of years ago video, but still it seems that the students are like working of their own and trying to solve some problem given by the teacher actually. Here you can see some students from Russia. We have, and I think most of them are now graduated, and many of them have got job actually. So I remember that some of them I meet usually, some students from Finland. He has graduated already. So I will go a little bit further to make. So what's the idea and what is this Savonia teaching strategy actually? So there is a term here, we call it CDIO, like conceive, design, implement, and operate. If you see applied science universities across the globe, there are like this approach is a very popular approach. And then on top of that, we use this OIS, Open Innovation Space, which you see here, Open Innovation Space, OIS. So this is one of the key things, CDIO plus OIS, I would say, the teaching methodology at engineering and technology. So problem-based learning, usually students are working in socially, they are how to, because it's a multicultural classes, so teamwork and social, of course, they are, we get, or the yield is coming quite nice actually, more innovative. For example, they are doing something, acquiring deep engineering competences, and particularly these methods which we have, we are like creating the workforce for this future IoT ecosystems, because this course was bachelor degree in Internet of Things program. So, and then of course, innovation is one of the key aspects for all, not only Finland, but all the Nordic. They are very small countries, but for innovation, they are very, we focus more on that as well. So there are a couple of things that I would like to say here. Finnish pedagogy focuses. So this is one of the, so Finland, you probably might have heard about Finnish education systems. It's I would say the first is literally teachers' autonomy and responsiveness, I would say, responsibility or responsiveness actually. So the idea is we have very good autonomy. This means that we have been given the curricula. Then as a teacher, need to decide. No one is looking at you what you are doing actually, and that is, I think, the faith and responsibleness and teachers' autonomy made Finnish education system, I think, very good. The three pillars which we have is creativity, novelty, and innovation. So I think many Indian universities also now they are focusing on these things, particularly like creativity. So this means that we create the environment for the students so that they would do something creative. They would do the things little bit elegantly, little bit differently, what world is doing actually. So that is, I think, of course, if we focus on the bachelor degree students, in bachelor degree, they are very new. They just come from 10+2 education, and probably they do not have much idea. But however, they are good at creativity, doing the things little bit elegantly. We always try to do elegantly means that which is like resource optimized, I would say, or I would say like energy efficient systems or so on. Then the second part is novelty. Novelty is really is also very key thing actually. Maybe at undergraduate level, we cannot focus more on novelty. Maybe these kids, very undergraduate student may not include some novel things. But the idea is our focus is that we try to do the things with some either very good comprehensive analysis, for example, or we could do something very novel way actually, and try students to get the in-depth knowledge about the things that they are doing actually in their courses. And then finally, innovation. Innovation is, I would say, it's in the Nordics blood actually, I would say. So innovation is also, we are focusing a lot, for example, doing the things, and innovation creates lots of businesses in the future actually. So these are four things that Finnish pedagogy, particularly in the domain of, I would say, engineering and technology, most of the universities, like we have like bigger universities, and also we have applied science universities. So both of them focusing these 4 points actually, which is needed here. Now so this is about a little bit Finnish pedagogy, and also about this Savonia University Applied Science and Finland. So I'm now talking a little bit, switching my gear towards some of the projects that I am involved with, and I will talk about some of the research results. As I told you, I have been actively involved in teaching in artificial intelligence. I teach like also third-year students basics of artificial intelligence, sensor technology. Now it's ongoing. Now here we have sensor technology, because when we say IoT, sensor is one of the prominent or the important part or important element, where smart in creating the things, making the things intelligent, we must have some sensors actually. So that kind of I'm going to talk a little bit with this national and EU level projects. So the first project that we have is UCN drone project. Here, probably you could see one of our article also, it's published, also unmanned aircraft system education activities in Finland, which you see here, UCN drone perspective. So we have been utilizing lots of some infrastructure wise. We have few drones also to do different types of research. For example, we have used drones for forest mapping. We have used drones for finding the thickness of snow in the winter region, climate or winter season. For example, we used a drone, and one of the publications that we did. But here in this, we have 10 universities and University of Applied Sciences. As I mentioned you, we have we have in this 3 bigger university and 7 University of Applied Sciences together. Total funding was approximately 850K, and it was ended 2 years ago actually. And we created a network model of universities, like what kind of research and what kind of education is necessary for Finnish students and also the international students who are coming to Finland. And in this project, my role was also the project manager and also as a PI, principal investigator for this. So the next project which we have here is Valifact, virtual learning environment in a smart mini factory. We have created this with our earlier project, which we called ATAL. ATAL means that automated technology, I would say, is in Finnish actually. So so we already have that factory, but in this project we utilize that factory to create the virtual learning environment. And it has, in this project, we created basically 5 modules actually, and 2 modules are for Savonia, where we are focusing on how to efficiently collect the data from sensors and send it to the cloud. So that is our one task. Another domain which we work, data-driven manufacturing. And then in this project, we have people from Germany and also from Denmark. So Denmark was working with these collaborative robots, and German guys were working on, I think, if I remember correctly, they're working on a smart factory, and they created some of this smart factory related Festo. They have Festo, and we have lots of visiting and like transnational meetings and so on. So the idea of this project was how, if you, for example, if you try to find some courses online for the smart factory, maybe you don't find much on the Google or anywhere if you find it. But then the question is like how ERP, like enterprise research planning. So then when you give order to the in the factory, how it processes goes to MES and then PLM, product lifecycle management. So that kind of learning environment courses have been created, and I haven't kept here, but these courses you can view still. It's valuefactory.eu is the website, and we have created actually this. I think this is still working. So I think end of this year probably we will have this website active, because from the projects itself we must have this documents or the modules ready on the website until 3 years of the end of the project. So now I move to our recent, which is ongoing project, and we call it Water Lab. Probably you know water is a very important asset for all of us, and we want the water, pure water to drink, for example, and lots of research are going on in this domain. Particularly one of the challenge in this domain is that probably, I don't know if you might have heard that in 2 years ago, there was a big cybersecurity attack on the water facilities in United States, particularly in Florida and some other places. And those attacks actually left the water facilities completely closed actually. So the idea of this is there are so many critical infrastructure like energy infrastructure or water infrastructures, what we have that must have very good secured, and I would say there are few terms actually. We call it PQC, probably some of you already know, post quantum cryptography, or nowadays we are it's a very trending word, is we call it quantum safe actually. because quantum computers and all of those things are coming and research are going so like very rapidly. So we call it also quantum safe. Actually. So these two ideas where we have did this experimentation, and if you see, so first of all, I would like to tell a little bit about our infrastructures that we have. So this is the kuopiowatercluster.com, which is part of our university campus. And I think Eero Antikainen, we have been closely working with him. He's the head of the research. We have been working very closely. I would say Kuopio Water Cluster is a network of university research institutions and companies dedicating to advanced clean water solutions, actually. So that is one of the key things. Lots of research, particularly in the field of water contamination, water flooding, and rainwater. So that kind of how to use, for example, harvest rainwater from the IoT technologies and so on. So this networks particularly concentrates the water sector research and development and innovation in this Pohjois-Savo region. So see, I said here, Pohjois-Savo is a regional area of Finland, which we call it North Savo. Pohjois means north, and Savo is Savonia region, we call it Savo region. We have two, basically, we have South Savo and North Savo. So North Savo, I would say it's in Kuopio, and also South Savo is in Mikkeli, which is a little bit south from here, 110, 115 kilometers south from here. The idea of this here, the Kuopio Water Cluster, is that we provide rapid product development, testing, and commercialization services. More than, I think, very many companies, I would say more than 50 smaller SMEs and bigger companies are associated with us, working lots of research. The project which I said, AQSEC, which you see here, now we have been very heavily cooperating with Nokia. Another, I would say, this SSH, probably you might have heard the name, company SSH. And then the third one which we have is Process. So, of course, earlier there were IFs and other F-Secure and other also involved. But now we are focusing more with Nokia, SSH, and Process. Process is a company which is dealing with most of this open platform communication, unified architecture standards, particularly in Europe and particularly in Finland, because OPC Foundation is one of the European secured kind of security standards, that is OPC Foundation. About this AQSEC project, which we have, its funding is approximately 1.2 million euros. It's funded by Business Finland. Business Finland have been recently focusing most like the regional development, country national development, and they are providing lots of money for the research. This project is going to end very soon, I think February 2026. So next year, February, we have already, I was attended this, our steering committee group meeting actually just a few days ago on 1st of October, 3-4 days ago. I was there also, so all the partners were showed their status, how this project is going. We have actually Savonia, Jyväskylä University is one of the very good university who is working on the domain of cybersecurity. They have their own SOC, like Cybersecurity Operations Center also. Nokia, probably you know, Nokia is now basically working with mostly with the network business. Earlier, Nokia was doing, Nokia has phone earlier, probably many of you know already, but now Nokia is not doing any phone productions actually. Of course, they have been doing little bit, but I wouldn't say much more. And then, but they are working very good with Internet of Things, networking business, 5G and 6G, network business, and so on. SSH, as I mentioned you already, and then Process, which is who is working mainly with this open platform communication unified architecture and these protocols that are being used in the critical infrastructures. For that, they are looking at. And then also earlier we talked a little bit with F-Secure, who is working on this front end, I would say, security solutions. So, but now we have not been working with this F-Secure. So we have some persons here involved in this project, actually AQSAT project. You can see this is I myself here. We have also Aki Hakkonen from Savonia, who is working with this Savonia development manager. One good thing is that I can tell you is from this business Finland project, we have hired one mobility person from IIT Mumbai actually. And he is this person actually, and he has been working with our cybersecurity AI-enabled systems actually. How in the water infrastructures, what kind of anomalies are there? For example, how you would know with the use of artificial intelligence algorithms. I will show you some of the results that we did to figure it out, like which sensors are more vulnerable, for example, in the water infrastructures. So we have Kanth actually, which you see here. He has been residing from, I think, Kolkata region, but now he is at Savonia University of Applied Science, and he has been working with me here at Savonia, and his position is actually postdoc research, but also his position is RDI expert in this area. We have Mikko Orjala. He's from Finland, and we actually he's working on this database management, because like when we talk about artificial intelligence, then the most important thing is data, from where our model learns actually, that we know already, like training and testing or the validating. So he is the guy looking at all the data sets actually. And then we have another project assistant. He is working on particularly on this smart factory side data, and also water cluster side. And we have some other project assistants who has been actively working. And I think there were some earlier also, some of them. And I think Aero is research, and Patrick, he is now no more. I think he's not working with Savonia project, but he is the one who gave the very good contribution and in the beginning of this project. So now I will talk like little bit about water things. We have been doing lots of things. So one of the area that is OPC UA that I mentioned earlier, platform communication unified architecture. How this architecture is being built in our system. That is one of the key questions actually. How security levels, for example, in different level of the instruments which we have, how this architecture could be built and how this architecture could be securely built. So this is which you see here. This is like the water, 3 layers of this, and there are, I think, we use some. This is the maybe OPC UA server here, if you say, and TwinCat is our engineering, TwinCat engineering, and then we use also TwinCat's own OPC UA, which goes to this our system here as a client, and then we build different self-built dashboards. Some of the project assistants build this. We used also Process OPC UA Forge, which is now currently being used for creating this tunneling between Savonia University of Applied Science and our Jyväskylä University. And then we have Unity. We used it. UA Expert is also one client that we have did the experimentation. Similarly, Node-RED and also Ignition HMI for creating the short, I would say, digital twin of the systems. So that kind of thing, we call it complete water loop OPC-UA, that includes all the standards which is given by or offered by this foundation actually. So this is one of the results that is shown here. We used the process OPCA monitor. There are a couple of visualization schemes, and which you see here is like different sensors in the water infrastructures which we have, and in those water infrastructures mainly we have like flow meters, for example, or temperature sensors, for example, or the pressure sensors. You can see the degree Celsius, 19 degrees Celsius, then pressure these are bar, for example, and then we have also pH meter. So I think now currently we have 69 sensors altogether, and we have been working on different AI modelings. This is just the visualization, but we are also working on how these AI models triggers or tells or give us insight, gives us insight which sensor is going to be broke, for example, in few days or something. So little bit predictive kind of maintenance thing that we are working on. This is a very short, like I would say, it's a digital replica. I wouldn't say this is digital twin actually, but of course this has been connected with, and this has been done with this HMI ignition HMI tool. I don't know, many of you probably have used already. Here we have this pump, and this is like valve actually, pressure valve, temperature sensor, flow meter, or then another flow meter and pressure gauge and all those things. And this has been integrated with our own system. So this is a very simple test we did as a digital replica, and it worked very nicely actually. And there were some challenges, I would say, when we were building it. The challenges were, for example, we do not have all the equipments that we have in our water infrastructure, for example. So that kind of things are being challenged because in HMI ignition library, all of those things, so students and also researchers were thinking to how to add those in their own library and put it on the, so that when we integrate it, we could see the different kind of optimization, for example, like if we change the pressure value, how things are working, or if we do the temperature, what are the effects and on other parameters and so on. So I think there is a small, maybe a few seconds of video where you could see that it's a real time and it's connected with the system. Now I think with the help of our other researchers, we have been, and also one company we are thinking to involve and creating the full-fledged digital twin for our water infrastructure. Probably this could be in our next some project actually. So let's go further. So this is the physical, you can see here, this is the physical water lab, which you can see downstairs. We have chemical industries, for example, labs actually here. Lots of chemistry related or biological related research and laboratory tests. We have been on the upper side. We have this, which you saw here. Actually, this is, if I go back, so this you say 3 layers of this piping, actually approximately 1.2 kilometer. So this is the pipe actually, and like all of those like L4, L3, L2, and so on, and all. So this is, I think I would say a very preliminary task for this digital. And as I showed you, this is the ongoing work, and we have one company actually who is very good at building the digital twin, and its name is 3D Talo, which we have been incorporating. But I think this cooperation was in kind, not any financially. So maybe we try to put this company in the next projects. directly beneficiary, and probably we could have more results on that. So I think this is a short video. Probably you can see here like how these data are changing and how. So this is the real-time data again with this in which water line and which how much pressure values and flow values and so on, and the level is also there. So I think I would like to show you this small video about this our water line premises and what we are doing. So maybe you could see here a little bit with this our student, actually our research assistant Kanth. He has worked on that, and maybe I can show you but all the visualizations what we did, Twin Cat engineering from where how OPC standard is being compliant. So these kind of things are available in this video. Let's have a look. So this is our PLCs. So there are some for safety reason we have highlighted this, made it. These are the I think IP addresses from where. So that was so that I showed you already. It's a process OPC data visualization for these different sensors. Another is historian, but now it is outdated, a little bit older one. So this is with the node RAID actually. Our research assistants have built this front end by themselves, and so this is the task actually. Let's move further actually. So these are some visualizations that you could see here, this is if you come to our water infrastructure, this you could see in our front gate actually, which is, and here in the background, as I mentioned to you, all of these visualizations which are ongoing and important alerting systems have been built, and this is our own technologies, and we at universities with the help of certain companies we have been building. Of course, as I told you earlier in this AQSEC project process, we use Process Forge evaluation trial software actually. Of course, these softwares are not built by us, but that software was built by Process actually, and we together did some experimentation, and actually this has added the level of security. So that is one of the key things nowadays in the critical infrastructures. So similarly, as I told you earlier, with our current APSEC projects, like we try to finding out like what kind of sensors are vulnerable, which sensors are going to break maybe in few days. So that kind of prediction with the AI models, actually with different databases we are doing now, and also we come up with some recommendations. For example, like, hey, these are the sensors, they might be a little bit vulnerable, for example, with the different AI evaluating parameters and so on. So this is another I can show you. We have used some LSTM based reconstruction error or the prediction, for example, and this is one of the machine learning algorithms, or sometimes we also use deep learning algorithms. We are using like now we have been using this LSTM variational autoencoder algorithm to see that with the data sets how this is behaving, and like what is the condition of this anomalies and so on. This is now a little bit, so earlier what we discussed, all things about this water infrastructure. Now we move our gear to a little bit talk about this smart factory kind of thing. So a smart factory, as you, I don't know if you have the bit, yeah, this is our smart factory. I will show you here, so let's go further here. So, so we have one master PLC here, and then 8 these slave PLCs, and then this HMI board is here, which is given by Siemens actually. So this is the idea here. We use process force. We use some other clients like UA Expert, visual components to create the 3D modeling and so on. And it has been like the Profinet master to slave connected with the Profinet, and then also ERP where you give the order, for example, in the factory. Like what kind of products that you want, for example. And there are 8 stations like IMS 3A, 3B, 4A, 4B, 5A, 5B, 6A, 6 and 7. And they are connected with this constant application protocol, actually. So this is the green, which you see, constant application protocol, and those are connected with Profinet. So this is the general architecture of this Savonia mini factory that we have here. We implemented this open platform communication unified architecture, which is in this factory actually, and at the same time we created also this virtual 3D modeling. I think there is one video that I am going to show you soon, where you would see that how efficiency of the factory, how resources optimization of the factory can be optimized, actually can be revealed, can be visualized in real time, and tweaking of one parameter, how it enhance the efficiency of the entire factory, for example. So that's the one of the idea. So I think this is this video, or no, this is not the, so this is our, what you saw, I can show you. So this is our slave PLC, which you saw here. This is 3A, 4A, 5B, 3B, 6 sites. So this is our, so if you see here, this side is our ERP, where you have some products here. We give like top, and this is the bottom. And then here, if you see, where is that? I think this is, I think here is somewhere you could see also the bolt actually. So these are the products, black, white, and also you can see the top, bottom part. This is top part. This is top white part. And also here, if you see, this is the bottom black part, bottom white part, top black and top white. And then here you have the bolt. Also, we have 2 colors of bolt, like plastic bolt and also metallic bolt. And if the product is being prepared, it goes through this checking here, which you see. We have the Bechtel camera. It checks the, for example, quality of the product, whether it is, because this has AI enabled so it compares with the real quality, and if it is passed, then it goes through this one. So this is idea of this smart factory. Here, I think we can see a small video where you could see how people and machines are interacted together. At this moment, I would say that in this video, our factory has not been integrated with this, but this is ongoing tasks we are doing now. So I hope what are like different node P, black one, and node white one, how is the production rate, and how is the people movement and its resources, and all of those things can be shown here in this video. Let's have a look. So I think this video, does not have this sound, any sound audio actually in this. So we have this ABB robot also we utilized, and this is Hanna, a girl actually who is kind of a factory worker. And when the product is 3 parts, which you see here, we have metallic bolt, plastic red bolt, white block top, and then it is the black bottom, and this is black, white top, and this is black top. So all 6 are here, getting one by one, which you saw already in the. So this is just a simulation model that one of my French student from France, he has built it, and you could see like how the factory is utilized, how far this travel has been done, which parts are transported, what is the last part. So all of these things are can be built with this visual component. So this is, we use visual components tool that we have used, and probably, and now we are working on this integration. I think we did already integration as well. So this is, I would say, it's working currently very fine actually. So with all the Hannas, like the ladies, for example, house is, and also like human and feeder count parts, how many has been prepared. This is in real time, you can see. So this is, I think, our own work, and we did from the very scratch. Actually, this has been done with very scratch level. Actually, all of these have been done with the very scratch, with the AutoCAD design startingly, and then adding components. You use Python programming. I think I remember some of the students use the Python programming also to create new products if they are not in the library. So that's how it makes sense actually to like how this utilization of the factory resources optimization, travel, parts are consumed, and so on. So I think this is maybe one of the digital twin and production efficiency and sustainability, we could say. Let's go further a little bit here. This is, I think, one of the deliverables that we need to suppose to give in our AQSEC project, where this is a part of Uvascula University, and this is Savonia University, and we have created this PQC compliant remote connection with very high speed 5G data connectivity, and we use the technology SSH, privileged access management, we call it PBX, and also in OPC UA server we call it process force. This is the process force. So these 2 technologies have been implemented with our smart factory to send both OT data. Now we have not talked more on the IT, because when we say smart factory or anything, we have 2 areas. One is information technology side, and another one is operational technology. So OT data. This means that we have the information about different operations, for example, like how many products are coming, what are the resources, and so on. So we are talking now mainly operational data here, and it sends to Uvascula, and they have the system where AI-enabled system is running, and it gives you more insights about your factory and so on. And this has been, so this is one of the key part of our project also. So this is what I said you here. So this is the procedure, how this had been done already. So we have this master smart factory here. You have OPC client where process forge had been used, and then previous extender at Savonia site, and this is the tunneling. And the big thing here, we call it PQC compliant tunnel, but the target is to have this quantum safe actually. So this is not ready yet, but I think in a year or maybe by end of December, SSH has told us that this tunneling would be quantum safe. So this is one of the biggest achievement if we could transfer the data with quantum safe mode actually. So this is very important for nowadays, countries geo things are not good. It's becoming a little bit going in a war direction. So I think you have to have your data more secured, more quantum safe, and so on. So I think this is one small video on this quantum safe PQC experimentation that we did. I think so. Let's have a look. I think this one. So now safety check is here, like quality check and assurance, and if it passes, it go further. So this is the whole. Okay, so this is, I think, the short video of our APSET project actually. So let's go further. I think we have, okay. So now I think I talk a little bit about some of the AI related research that we got actually. So as I told you earlier, we use this LSTM variational autoencoder. Actually, Kanth from our team, he has mainly worked with that. And we have like altogether 69 sensors. I think this is a little bit older. We need now again, parameters have been refined. We did, and I think we have even better result. This result is maybe 1 month before. So with 20 sensors, it gives very good accuracy, precision, recall value, F1 score. If you see the confusion matrix, only like the true and false were quite very big, small number actually. So good numbers are giving you and this is our like 640K into 73. 73 are the 73 means that these are the features of this data, and these are all timestamp data actually. So if you see March 2026 actually, so last spring we got this data, and we have a huge number of data, and we are thinking to put this data. So for example, if maybe from any Indian universities or researchers, if you are working with in this domain, probably because Singapore has we have very collaboration with Singapore. Singapore has already published their data sets, which other researchers are working with that. We have also worked with their data sets, but then we have created our own also. So I think Singapore University of Technology and Design, we have been collaborating. This is a little bit attribute of SAP analysis, which means that here I think we have 20 most important sensors that we see, and what is like the attack behaviors, like valve manipulation, flow spoofing, overheating or cooling disruption, or the pump command tampering. So which are those? So with these methods, actually SAP analysis, we could know in the real time. And then we have a little bit profiling of those sensors, which is one of the tasks in our as a deliverables for this business plan project actually. So based on we do the delta F1 drop. So like which one is the critical, which is high. So this is a little bit profiling we did, which is moderate, which sensors are, for example, if you say moderate L0P1, so this is L0P1 is this sensors and so on, very low, negligible, and none, for example. So this is kind of a little bit profiling. Now I move to a little bit object detection that I mentioned to you earlier. So one of our research result with the collaboration with the University of Turku, Finland. If you see, this is the, as I mentioned to you, trucks, cars, human beings, trams, and buses. The idea of this, and this is the methodologies flowchart. For example, you need to clean the data, stream analysis, download. You have like some temporal and spatial variations. Temporal spatial variations meaning that time-wise, like in the night time, in the daytime, also spatial variation. And then the students have used the annotated tool, and then they have created like categorization of the classes, data set preparation, and then analysis and model training was done. This has been a very good result actually. So like we call it YOLO, which is you look once. So that is I think the full name, and many I think machine learning object detection algorithms, if you are working with, probably you are aware of this. And we in this work actually we have trained like 5 classes here: trucks, cars, humans, trams, and buses. I think there is one videos that I don't know if there is a video or not. Yeah, we have video as well. So I will show you here. So I think then it would make good sense here. So this is the precision. The idea of this work was we have not done anything with the algorithms, because YOLO 8, 9, 10, and so on, they are arbitrary. They are being already in the market already. So, but for this work with our own data sets, we tried which algorithm suits better actually. And for this, I think we found, maybe you can see here, this is with YOLO V10. So the prediction class is very nice with the true and the predictive, which you see. And this is like mean error and the precision, recall, F1 score, and inference time. So you can see here. This is this we have submitted, I think, last year actually in MNIT Jaipur, and our paper here got this best paper award also. I think this is last year, I think, if I remember correctly, and I think I attended that conference as well. It's a SOCTA 24. So here you can see this is little bit result here. We have created 2 lines here. This is up line and down line. for example, which is coming and going, for example, and it would see like 5 classes like car, vans, trucks, human being. Human being prediction is a little bit difficult. Like you see, human is 80.80%. When you have car, it gives you very good accuracy, like 95% and so on. Human, which is far from this, sometimes it's a bit difficult. But let's have a look. Of course, this any model which we have, every time we need to hyper tune actually. But so far, it's working quite fine actually. So you can see, like if the trucks are very big and they are almost, you can see this is the, so human being also, if people are like, ladies is moving. And then there is a question here is that we must follow this GDPR rule of Europe. Actually, we are not supposed to show anything of this, of the personal, for example, registration number of the car, for example, or human being could not be recognized. This is one of the challenge. And as I told you here, if you see the first, so here with this, see that our undergraduate students for 2 years they have worked with just annotation of with this data actually. So this is, I think, we go further. So now this is, I think, few more slides on this robotics. So we have been very heavily also working. This is our Savonia campus, which you see here in Finland. This is the front side, a gate actually from where you can go into the into the building. Quadruple robot autonomous navigation. We used here. It has like some arm here. And this is unitary robot. This we call it Bob or Alice. No, Bob, I think. Yeah, we have this. We use Bob. It has also this LiDAR sensor, which you see here. This LiDAR sensor gives you the point cloud data. Of course, the quantum, computational complexity is high, but still we get very good results. So LiDAR, light detection and ranging in navigation and mapping the performance for these autonomous systems. The questions, another research question for this work was, how can the motion planning of robots' arms be done and how can it integrate with the autonomous movement of robot? So this is one of the tasks because this is the arm and this is the robot. Both are, and this is very heavy actually, by the way. Even this robot, if you see, it's over 50 kilograms. So this is quite heavy. It has, I think, Jefferson Nano and Raspberry computer inside, I think, and it works quite fine. It is capable of computing AI algorithms as well with this huge amount of point cloud data from this LiDAR sensor. Another research question was, how can we provide autonomous functionalities of this Unitary V1 using Unitary software development kit? So there are 4 things that we work for this autonomous navigation. One is this light detection and ranging, which is the LiDAR sensor. Second one is this SLAM, simultaneous localization and mapping. And then third one is some algorithms, ready-made algorithms, which are already in the market, like adaptive Monte Carlo localization, we call it. And then move base is one of these simulation environment move base with Gazebo and some other tools that students have used. These are some of the results that we got actually. So this is we have been given the destination where this robot should be reached. Also avoiding all the obstacles in the runtime. So this is one of the tasks. Now, recently, we have been doing the same thing with reinforcement learning. Here, we have not used any RL algorithm, but now one of the Chinese students who is working with me now, he has implemented already RL algorithm. Still, the model is a bit confusing, but I would say that this is working quite fine. Actually, it avoids all the obstacles. It doesn't touch. But here in this work, we used point cloud data from this LiDAR sensor, but I think I can show you just after this video actually there. I think I'm not sure if I have included that slide here or not. So this is the video based on this SLAM methodology. This video is not that good in the quality, but let's have a look. It is following actually. So one of my thesis students had worked on this, and he has worked nicely on this. For example, so this is the guy who is working with me. He evaluated, I think, this year, this spring. Yes. So it is. Yeah, so it turns now a bit confused also, but I think it's now, yeah, so it avoids the obstacle that we see. So localization and things are visualized in the private side also. So maybe, oh, sorry, just give me a second. Yes, so I think now I move to the next slide here. This is a similar work that has been done with University of Eastern Finland, and where they have tried to train this robot to be used in the healthcare surgery room actually. So now they are working on that. So this is which you see here. This is the, I think, what's the name? It's a Stereo robot, Stereo, if you see here, Stereo mobile robot, that is, and this has been created here. And the 3D modeling with IVs, RVs, for example, RVs is one of this ROS-based systems, so they have used, and we used also, so all avoiding mechanism and so on. And this has been, I think, work has been also submitted for a conference, and I think we got accepted these publications actually. So soon this will be published. Now, a couple of few more slides that I'm going to talk on this 5G environment that we have been working with. So I can show you here, if you see here in these videos, maybe you could see that reinforcement. Let's see this one maybe. Okay, this is not working. Okay, let's see. I think. No, this is, I don't know, this is, but here what we have done, AI-driven autonomous robot on the 5G network. Here we have checked, is this the video? Let me check. Is this the video? No, this video is also not working. So I think I can show you later, but I think somehow it is not working. So in these two videos, actually what we did is reinforcement learning to train this bingo robot. I don't know why this video is not working anymore. So the idea of this, here we have compared the high data rate of this 5G and also low latency communication of 5G over Wi-Fi technology. So in Wi-Fi technology, we noticed that they hit the target most of the time because of low, bigger response time. But with 5G, as it is, that delay is quite smaller, so it avoids in the runtime also. So that is the idea of these two. I don't know if I can show you here or not. No, I think this is somehow it's not working for now. Anyway, so now I think what is this video? Okay, yeah. So this is some of the students that have been working with like sorting. This is students' work, maybe you can think of, and these robots are really very cheaper nowadays. It gives you 3,000–4,000 euro. This is Nirio, which is a French robot. We bought it, and here the idea of this is this has a camera, USB camera, which is connected to the knob in the eye, and it says these two bolt and this, for example, wing nut. wing nut bolt, for example, this one, and this is the bolt and wing nut, for example, this one, and this has been given a program here which has a capacity to detect whether what kind of object is here. For example, this is wing nut and this is bolt. So the idea of this project is that, and this is students' project in the course actually. So this is not any project, bigger project work. It's a class work that the students have done with multicultural group actually. And the idea of this project is to how robots could be utilized in a workspace to sort different kind of things. And this is usually in any factory environment, if you see. So this is now wing nut and this is bolt, which you see here. We also tested with this plain bolt and threaded bolt, but it worked quite nicely with the threaded bolt and it worked. So let's have a look. So this has been given, all the wing nuts have been sorted from the workspace. So when there are no wing nuts now, then robots will go and stop here. So because they have been trained to only to pick the wing nuts, not the bolt. So this is like sorting kind of things that can be done easily. Very shortly, I'm going to talk on this few solar cells kind of research that my PhD students have done earlier. We have created this is actually not realized, but it is simulation based. It gives a very good result actually with this 800 nanometer, very good quantum efficiency, approximately 74%, something like that, with the artificial neural network we use here, and to optimize which semiconductor material that is being made actually with the solar cell and so on. So the idea process is like this. For example, you can see the process is like this. This is the data sets from SCAP data, and then you feed into the network model, and then you choose the training and test selection, and then use some common algorithm, common neural network, and then data selection and algorithm, and you get this results, for example. So, of course, here result is quite good in the sense of errors are very less and near to this. So, and then this is very, I would say, efficiency gives very, and it took actually only 30 seconds actually. So that's one of the key things of this, and this has been published also, I think, a few years ago. So I think we have a few minutes time now actually. So this is my last slide actually before I stop. So at Savonia, as I mentioned you, the Shabilahti hub, which we have here, lots of building you can see here, and these are some of those buildings are Savonia's building, also university's building. We create a very smart kind of infrastructure with we have applied science universities, vocational school, bigger university of Eastern Finland, also Kuopio University Hospital. So these all we have been working, and then over 100, as I mentioned to you, these are some of the IT companies like Finvector, Honeywell, Delphin. We all are surrounding maybe 1 kilometer square. All of those companies are situating to our premises and cooperating with them in different projects and different students who work. Yaktikuko is waste management, also Fujitsu, then also GE Healthcare, Sensoftia. We have been, many of our students goes to Finvector, Honeywell. Also, we have some companies little bit far from here, like Ponce or Normet. They are working on, like Ponce is working on, like forest forest, I would say, manufacturing equipment they build actually, and then Normet is working on a little bit of software, and also they have manufacturing like tunneling and tunnels and so on. So that kind of thing is there. So this is all my slide. Thank you very much for your patience for listening this 1.5 hours of my talk. So thank you very much. So if you have any questions or anything, I would love to. So thank you so much.
Yeah, thank you, Professor Rajeev, for your nice lecture, various insights about the research work, what you people are doing. So I request all the participants, if you have any question, you can post or you can unmute and ask to Professor Rajeev.